Good morning, good afternoon, good evening. Welcome to the CSAS webinar on Gen AI governance and creating a secure, responsible, and trustworthy AI systems. I welcome each one of you to this wonderful session. And Naveen Krishnamurthy. I head CISA Canada, part of the CISA North American team, and I'll quickly walk you through the intro before I pass the mic to Dr. Anjan and Dr. Varghese. Yeah. So to give you a quick brief about CISA, introduction about intro about CISA. CISA is been operating for more than 18 years now. We are one of the top four global payment forensic investigators. And in short, CISA is a company, a cybersecurity and forensics company for the digital payment industry. We have at any given point of time, we have had 1,000 plus engagements, more than 10,000 plus client engagements globally. And we are, as I said previously, we are one of the leading global PCI forensic investigators with a very strong presence in the fintech and the financial space. Okay, next slide, please. To give you a quick overview about CISA's global presence in terms of companies that we are in the places and the countries we operate out of. The global headquarters is based out of Bangalore. We have 3 offices in India. We operate out of Canada, US. We have our presence in Europe, from UK. We have a pretty large presence in Middle East and APAC. So, yeah. Now to give you a quick intro about the 2 speakers today. Renju is our Vice President for Research and Development. He spearheads the AI Prism initiative. He's been with CISA for more than 18 years. He has around 18 years of experience in cybersecurity and cybersecurity solutions. He has been part of major initiatives in CISA. Renju is one of the co-author for an NAB accredited certification program, and he's also a CSP. He's a certified CSP AI practitioner. He has also developed patent pending solutions, including AI model across scanning solutions for responsible AI and compliance. He has been a critical editor and also a presenter for CISA's threat report that we publish regularly. And to speak about some of his certifications, he's been the Vice President for Leading Tech since April 2021, and he's been the Vice President for Cyber Resilience from 2019 up until now. He's a certified, he's a CISP, he's a Certified Information Security Auditor, and he's also a part of a core forensic investigation team. He heads CISA's PFI team end-to-end. He's also a 3DS assessor, and he's a qualified pin-to-pin encryption assessor too. He's been part of the payment card industry for more than 18 to 19 years now. Next slide, please. To speak about Dr. Anjan, our second speaker here, Dr. Anjan is a seasoned cybersecurity expert, yet again with more than 18 plus years of experience spanning. We call him Dr. Anjan, as his name says here. He's got around 75 publications. He is an author. He's co-authored quite a few books. Dr. Anjan is renowned for bridging the gap between advanced research and practical implementation, having successfully translated cutting-edge innovations into market-ready cybersecurity products at a global deployment level. He has previously worked with the likes of Wipro. He was part of the Wipro BITS Pilani WILP program, mentoring future cybersecurity professionals. And Dr. Anjan is also an active member of several professional bodies. He's got around 20 plus certifications. His certifications also include cybersecurity and IoT, managing network security, and introduction to cybersecurity for business. He's a PhD holder from the RV College of Engineering. He was awarded the best PhD thesis by the BITES Karnataka. He's also an MTech. And to speak of some of his awards, he received the Best Research Award for Project in Kleptography. He is the IEEE Best Research Award for 2020. He was also awarded the Emerging Researcher Award for 2022 by IEEE CS chapter. He has published around 2 books and over 75 research papers, including 19 Scopus indexed publications. His curriculum is recognized for the overall development in AI and machine learning and cybersecurity. Cybersecurity in AI and AI on cybersecurity has been his forte. So with that, I'll let Dr. Anjan do the talking. Dr. Anjan, you're on mute.
Am I audible now?
Yes, Dr. Anjan, please.
Yeah. Sorry for that.
Before that, a few house rules. It'll be a 60-minute session. 50 minutes for the session, and in the end, I'll be opening the house for a 10-minute Q&A. Thank you.
Okay. Thanks for that intro, Naveen. And let's start our journey with the machine learning and Gen AI. Right? Although we know that the AI world has ever expanded with a lot of advancements today globally and has been adopted at a lightning speed, it's very important to come at a very nascent stage and understand what's happening with AI and how does AI keeps improving with its way in which we go through it. I would like to navigate this entire scenario of machine learning and Gen AI with a simple examples so that it's very, very clear for us and we are on the same page today. So if you look at any AI systems today, the AI systems have one thing in common, which is that wherever it has been put into, they are in the either in the prediction or in looking at some kind of a thing, and it's based on the understanding and the learning, which is basically on that particular environment. So AI basically, if we look at the case of AI trying to predict the rain and trying to plan a traffic, right? And let's say that we have a bot and outstanding out in the rain and trying to do this. So how does it basically do? What is that it basically tries looking at? So the first thing what you look at is it observes pattern and it observes how people and the environment is basically trying to react to this particular environment and when it starts raining. And with that pattern, what it is looking at in the entire environment, the next thing what it looks at is that there are different rules which basically comes out. So out of this pattern, you start evolving the kind of rule pattern, which is like cloud means rain, rain means lower traffic, and similar scenarios with respect to that, which is basically different elements which are there in that particular ecosystem, which is used for predicting or doing a particular task. Uh, the real life, there are multiple different factors which AI basically has to learn, combine these to ensure that there are effective outcomes with respect to it. and thereby it basically looks into thousands of different examples and scenarios of what happens when there is a rain, and there are multiple possibilities of combinations which basically happens with respect to it. So this pro and combinations are the combinations where it will basically learn about what happens in different environments where there are changes in different patterns in this particular environment. So with that, what it basically draws a conclusion is that 80% of chance is that there is a traffic jam when there is a rain happening. So it will likely rain heavily when there is, and traffic will slow down. So this is the conclusion what it basically draws by looking into different options which was there in the different scenarios of that particular example. Going further ahead, it also does the entire improvement experience where it improves upon learning day by day and trying to make this entire prediction more accurate. AI models are not that accurate when they basically start off, and when they start working on the same kind of task and they do a repetitive learning on that particular environment, that is where it starts improving its accuracy over a period of time. So that is something which is very important in any kind of AI models. So AI is learn, adapt, and try to understand the entire environment, and then try doing a prediction with respect to it. It's like you just check the weather before you head out for it, and that's how the AI basically works with respect to this. And the AI keeps learning with respect to that environment, and it starts adapting to the dynamic changes which basically happens in that particular environment. So with that, let us go through another important summary line which comes with this machine learning. The entire machine learning construct is nothing but it revolves around the entire data set, where you have an appropriate data set where the machine can basically learn on that particular data set, perform computation, which is a combination of pattern, rule, and relation stitched together with a kind of an algorithm which can operate on this particular data set, and then finally output decisions based on that. So this is a summarized view of ML algorithm. We have supervised learning, we have unsupervised learning, and we have reinforcement learning. Basically, the difference is between the kind of data set that we are trying to handle. In case if you have a labeled data set, you go for a supervised learning. In case if you have a unsupervised data set, you go for unlabeled data set, you go for an unsupervised learning. And then if you want to look at scalable data in terms of trial and error and trying to do a corrections with respect to the results and the outcomes, that is where you go for the reinforcement learning part of it. And this is a candidate algorithms which are there under each of these is a learning set. So, and each of these use cases which are basically used for each of these learning patterns, and what are the benefits as well as the similar algorithms which are there. And if you go out there to many of the experimental setups where you try to learn about the machine learning, there are at least a dozen plus of machine learning algorithms which can navigate you through the supervised, unsupervised, as well as the reinforcement learning methods. And each one of them with a better accuracy, better kind of a prediction, and trying to look out for better reasoning out of the entire model and so on. And it's also very important that we come into the case of deep learning. Machine learning was good. It was able to do multiple tasks, and it was able to navigate over the data set, but it required multiple different function and the candidate algorithm to do a particular application objective. Now, if the application objective is to identify a particular object, it had to do a feature extraction and classification as a two-stage process before the final outcome is basically drawn on it. So to avoid that and to ensure that there is a much cohesive and a better way of training the data and also have multiple layers, which can do both of these feature extraction as well as classification, there came the case of deep learning, which could basically be on the case of neural networks, which exactly mimics a human brain and a human neural network, where each neuron can do an active work and a computation on what is assigned to it, and then pass on that particular experience to the neurons in the layers ahead, till the point where we come across with the final layer, which is capable of drawing the output about a particular object. So this became very popular in the 2010 and onwards, where a lot of applications started coming up with the deep neural networks. So the neural network are the case where in which you have input layer, hidden layer, and the output layer. The input layer, the neurons which are involved in the input layers are nodes which are basically trying to correspond to the input data features. The hidden layers are the heavy lifting ones where they basically try working on multiple different hidden layers, and each layers are talking about how do you transform that particular input into something on the output layer, and what is the kind of transformation that the neurons are basically required to do so. And finally, the output layers, which are the final outcome drawers, which basically draws the outcome of the entire hidden layers, and maybe a specific task like classification or regression, which is basically assigned on it, is basically worked upon. And this is the entire nutshell in a very simple manner and a very simplistic way being put across. And neural network today itself is a very huge science, and the expanded concepts which come run into pages together in terms of the research and other things what we talk about. With that, what we look at is the case of the transformer architecture, where we are looking at the core part of the today's modern Gen AI architecture, which is the large language models. And the large language models come with this transformer architecture once the one which was introduced in 2017, where attention is what all you need in the Google Cloud conference. And that was the remarkable change in the history of entire artificial intelligence, where the Gen AI started coming into picture, and we started seeing large language models like GPT and other followers after that. So the entire transformer architecture comes with a two-stage process, one an encoder and a decoder. The encoder phase is basically that the machine needs to understand about the user input. We are all aware that missions are in the ages of binary computing, which is from zeros and ones. They don't understand a human language as what we speak, and they are required to make understand about it. And that understanding process or the comprehending process for the mission is what we call as encoders. And the encoders is a five-phase process, which is like just as simple as you have a big pizza and you're just cutting that into small pieces in the tokenization step. So a large sentence is chunked out into individual words. We are just putting it across in a very simple way and breaking it into small pieces so that it's digestible. Then this individual tokens are not sufficient enough, because tokens are again not understandable by the mission. What mission can understand basically are numbers. So you create numbers, something like barcode or something like vector, which we call as, which are nothing but the embeddings where the numbers corresponds to the tokens. And then again, you add each of these tokens and the embeddings GPS coordinates. It's like how the language should basically read. What should be read first, what should be read second and third. It's the order of reading in any particular language, right? And then we look at the self-attention, where we talk about the finding the clues of what is the most focal point in this entire sentence that we need to give a focus on. And finally, the fifth step in the encoder step is the feed-forward neural network layer, where each word is a personal calculator, and you start calculating and understanding the way in which they are, having a mutual attention towards, and the neural network starts doing a prediction. So this completes the stage one process of the transformer architecture. And then we go to the stage two, which is the decoder stage, where we generate the output. So when we generate the output, it's again a four-stage process or a four-phase process, inclusive of self-attentions on the output statement, what needs to be created. And then it goes into the cross attention between the words, where there is an encoder decoder attentions. Between the stages, there are a lot of attentions which are basically required. A feed forward network basically starts doing the prediction job, which is required for each of these attentions, what are done. And then there is an output prediction and probability of what needs to be generated as the next word. So this is a continual process in the decoder stage until unless you come across a stopping criteria where it stops the output prediction part of it. So you have multiple different examples of how this entire architecture works. It's a very decoded format and a very simplistic way of how this encoder decoder mechanism works in a transformer architecture. Although the original paper which has been there in the way back 8 years is fairly complicated in understanding it, and it's a very simple way of looking of how each phases in the encoder as well as the decoder basically works and what is its basic significance. It's just decoded in a very simplistic way. So with that, let's go and understand what is the process that we brought in AI for. We brought in AI in this entire ecosystem to make automations of many manual processes. Now, if you take an example of driving a car, so the traditional machine learning, which was introduced way back in 90s, are like manual cars, which needs human input and supervision to function at every point. And all the hyperparameters which are there in the machine learning needs to be monitored with several different controls as what you see in a car to be monitored. And then what we did was we moved across with ML systems a step ahead of it, where we started looking at the automatic cars, which are easier to navigate than the manual ones. And but still, it requires a driver to work on it. Then we came in the era of generative AI, where we started looking at an adaptive cruise control mechanisms, which can learn the environment and start adapting to it, and can handle certain tasks dynamically with respect to that particular environment, something like a lane management, lane driving, lane self-driving, and things like that. We wanted to do this entire process. Our objective was to make the entire process automatic and it's driverless. So we went ahead with the next step where we started introducing an agentic AI concept, right, which is a very popular keywords in the last couple of months. So with the agentic AI construct, we can see that the agentic AI talks about autonomous vehicles which can perceive, plan, decide, act independently to achieve goals. There is nobody sitting on the driver's seat. There is nobody there on the driver's seat as well, and it takes the decision to go ahead with respect to the entire process. It's a combination of perception, actuators, the decision engines, and multiple different elements which are trying to coordinate with each other and trying to do a independent job of decision making and with less or no human intervention at all in the entire process. Um, where the entire process is like a human brain trying to work on this driving cars. Believe me, I have been there in the Waymo car and I can understand the kind of marvel what it has created with the agentic AI concept, right? So it's a very nice concept to drive through, and that's where the entire world is headed towards in the AI, where you start automating the entire system. And that level of automation is something which is commendable and equivalent to that of a human intelligence, although that is a very, very far off desire in the entire history of artificial intelligence. That's where AI is basically headed towards. And what we are now is in a narrow AI where we are just trying to do a task generation and following a particular set of tasks to be done. But AI in the future is something like trying to judiciously take its decision independently and be far independent in terms of its intelligence. So with that, I would request Ranju to take over from here.
Sure. Thanks, Dr. Ranjan. So, we talked about the basic AI, right? Now, let's talk about how is the LLM is being, or how is the AI is being used within the application in the organizations. So, as you all know, in the traditional application deployments, it's where we have a user accessing the application via various interfaces. Then we have an application where the entire logic is running, and we have a database where the data gets resided, and the application basically retrieves the data from database and interacts with the user. Now, for the past 2 decades part, we have been seeing a lot of ML deployments, right? So if you actually see how it works, it's basically gets triggered within an application workflow, right? So it's mainly a user driven application workflow. So whether it is an image, voice, or a sensory data. And when the data comes in, the application basically is going to call a machine learning models, right? And these machine learning models will be hosted within the same environment or same cloud environment, and then process the data and process it. Various examples, just look at your Alexa or your Apple Siri, or just look at any document retrieval data set, all works on an ML algorithm in the backend. The first ML algo, which I personally came or personally knew about it, is the YouTube ML algorithm for determining which videos do we watch. Um, in the security field, we have seen a lot of MLs being deployed, especially for the anomaly detection, for your fraud analysis, or anomaly detection for your security monitoring teams. So ML deployments has been there for a few decades now. And on the year 2022, November, we got ChatGPT, right? So in the initial deployments of the LLMs, what you've seen is that the organizations have just directly integrated the applications with the OpenAI, like ChatGPT, via an API call, right? So it was just a direct chat interface. And in the initial days, this kind of integrations was called Copilot, not Microsoft Copilot. It was just called as Copilot. But as it was just only a direct chat interface, after this initial few months, this kind of deployments went away. Please note that when in the entire slide, when we talk about LLM, there are two ways in which the LLM can be hosted. One, you can have your application directly calling the API of the AI providers like OpenAI, Gemini, Cloud, etc. Or you can host your own LLM within your cloud environment or within your data center. So if you go to various model hubs, you can get these LLMs, right? And you can deploy these LLMs within your environment itself. Sure. So the next type of the actual systems being used was we observed in the business process outsourcing industry, the BPO and the KPO industry, where the uh, in the industry, these applications, the images or the voice was being taken, right? So basically, in the BPO industry, all your recordings used to be processed by a machine learning model, retrieve uh, the run through your voice and retrieve the test component, and then send it to an LLM for summarization. Basically, test summarization or a call summarization to understand how your calls went, right? So through this deployments, we have seen a lot of quality check being, or a lot of QA activities being automated. We also have an image retrieval that we have seen, so which is now common in most of the applications. But in the initial ones, in the KPO industry, we had these kind of deployments were the doctor prescription. So we have an ML algorithm to understand the doctor prescription, retrieve those data, and then send it to an LLM to validate whether the data retrieved is valid, and to understand whether uh, the symptoms and the medicines which was being prescribed is proper using the LLM in the backend. So these are the second types of deployments that we saw in the industry. The third one type we saw was where the documents is been directly being sent to LLM for any some for an analysis and able to give a decision part. The first type of this kind of deployments we observed in the HRMS application, your human resource management system, where the resumes which is being uploaded is being sent to an LLM for automated analysis and able to identify whether that particular resume is actually fits to that job description for that particular open role. There has been a lot of these document analysis kind of deployments. Even within CISA, we have a product called CISA Assistant, which is a GRC tool, which has been used by our team for various audits. Uh, so in that module, when our client uploads any evidence, we have the AI integrated, which basically analyze that evidence and confirm whether the evidence meets that specific requirement or the action point. So there are a lot of this kind of deployments that we have observed. But till now, if you have seen, it's been always a user inputted uh, data which has been processed, right? So it has been a document or a kind of a voice interactions being inputted. It has not been used any data within its within the environment part, right, or within the organization part. So that's what we see in the next type of deployments, where the client used something called as the RAG database. RAG stands for retrieval, augmented, and generative part, right? So RAG is a kind of like a vector database. So what happens here is the organizations uploads their own data set into a RAG database or a vector database. And when an user queries the application, the query is sent to these RAG database or the vector database for retrieving the specific retrieving specific context linked to a particular query. And then both the context and the user query is being sent to LLM for generating an response. So here, organizations are able to use AI systems with their own data set and ensuring that the user is able to have a much more accurate response coming from the LLM. The initial deployments and most of deployments that we have seen here is basically organizations are using these kind of deployments for their internal uh, agents, right? So, for example, it is an IT agent. So all your user queries related to your IT related queries can be answered by the agents. We have HR agents, which can actually answer a lot of HR related queries. We also seen these agents being these both agents working for your chatbots with all the SOPs, standard operating procedures, and technical FAQs being integrated within the RAG system itself. So here you're able to have a lot of the organizational data for that user prompt, thereby improving the accuracy of the user queries. But here there's a limitation because only a generic set of data can be put into a RAG. You cannot have client specific or customer specific information in the RAG because there is a chance of customer informations being leaked out for other users. So to answer that one, the fifth type of deployments we have seen were the in the deployments part, where there are two kind of LLMs running, right? So when a user sends a query, the application sends that query to an LLM, say in our example, LLM2, for identifying what is the database queries to be run for that particular user query part, right? So here, when a user queries saying that, okay, um, please analyze my last 1 month bank statement. So the application gets that particular query, sends it to LLM2 to state that, hey, for running this or for answering this particular user prompt, what database query should I run? So LLM2 sends that particular query statement back, and an application queries your database, retrieves those specific data related to that particular user, and sends both the prompt and data to the LLM for answering it back. So in this way, the application can ensure that your user specific or customer specific data you're able to retrieve and able to answer back to the user. This is the most common kind of deployments that we have seen these days, and this has been now able to be gone into a much larger scale with the support of MCP, which is an MCP is a protocol which can be used to interact by the application to various LLMs and various database, and thereby able to scale this architecture to the next level. Now, till now, we have been talking about a direct application and just direct AI integration, while these days you'll be hearing the word agentic AI. So we have some few use case on how the agentic AI works. So we have a product called Provide. So we provide MXDR service and monitoring service for our clients. So initially, when we wanted to integrate the AI to our product. So this product is basically an advanced SIM solution. So as for the data, we have the logs, and we have our ML layer and our rule-based logic layer, which runs on these logs, and we get an alert. Now, the goal of integrating AI was to ensure that we reduce the false positives, right? So if you're being in the or if you have a monitoring team, one of the biggest challenge in every monitoring a team or organizations is that the number of false positive is very high. So we wanted to ensure that we can reduce the false positives and increase the true positive part. So what we did was we basically once we get these alerts, we send these alerts to a LLM, and we used a chain of thought prompting technique to see whether the alert was true positive or a false positive. A chain of prompting technique is a technique which has been used for able to chain various prompts so that you can able to determine how a human being thinks, or able to uh, replicate how a human mind thinks. So in this one, we just set a prompt once to say that analyze this alert as true positive or false positive, and ask whether the LLM needs an additional set of logs to determine that one. And if yes, then ask the LLM to say that, okay, give me those Elasticsearch query for fetching those additional logs. Then query the Elasticsearch and send those additional logs to the LLM for determining whether the alert was true positive or false positive. Elasticsearch, because we used Elasticsearch in the backend for our log management. But there was a lot of limitations in this system. Even though we achieved a 50% reduction, there was still a lot of limitations because it was limited based on the chain of thought prompts or the prompt engineering model, and it was not self-learning in nature. and not dynamic as well. So what we did, we went with the agentic AI aspect, right? So this is a use case perspective. This for the same thing can be deployed for various applications. We're just explaining it so that as a use case, so that you're able to understand the concept and you can use it for your applications. So here we still have the data, which is the logs, and these logs was sent to our agent one. Our agent one, it was nothing, is basically running our ML algorithms, and we have our UEBA correlation rules running those algorithms part. Now agent one generates the alert, and this alert is sent to something called as the orchestration layer, okay, or orchestration agent. So the orchestration agent is basically the brain behind your entire agentic AI aspect, which determines that at which point should the traffic or the data should be gone to. Now, in the orchestration agent, we specified the goal. So the goal of the orchestration agent is to ensure that to confirm whether the alert is a true positive or a false positive, and what actions to be taken in case if the agent is, or what actions to be taken if to mitigate that particular incident. Now, once the alert uh, comes from agent one to the orchestration agent, it sends to an agent two, which is an LLM. So we used Falcon LLM. Now we're using Llama LLM here, just to triage that particular alert and just expanded alert better. Now, once that uh, agent to triage that particular alert, it goes to our agent tree, which is our investigator agent. Now, this investigator agent is again a Llama LLM with a RAG system in place. Now, in this RAG, we have a lot of data which contains all the historical incidents and tickets related to that particular client. It includes the client's architecture, what kind of preventive controls has been implemented by the client, what all ecosystems and what all EDR solutions has been deployed, and whether also the latest vulnerability report of that particular client. So if you actually see the investigator agent, because it has a RAG, has a lot of data, which through which it can is able to make a much more uh, or it has a lot of context so that it can able to generate a much more accurate answer part. Now, if the investigator agent wants more data set, then we do have an integration agent, which is nothing but a set of tools which integrates with the existing set of solutions of the client, like EDRs, firewalls, etc. So if the agent three, the investigator agent wants more data, then instead of we directly querying their system database and everything, the orchestration agent routes that particular request to integration agent for retrieving those data directly from your EDR and firewall solutions. If it wants external data, we have an agent 5, which is basically connects to your threat intel database like VirusTotal for retrieving those informations. Now, once the agent 3 or the investigator agent is able to retrieve those informations, then it's again sent to a QA agent, which is agent 6, to basically validate whether the process on which the investigator agent has confirmed the incident is correct or not. If there is any challenge, then the QA agent sends that particular feedback back to the agent tree, which basically ensures that the agent tree has or is updated uh, with the QA pointers. So there is a kind of a self-learning loop there. And last, we have the agent 7. So in case if you want to take any action, you have a SOAR system implemented for taking any action part. So if you see in this entire agentic AI construct, it's not only using a multiple set of LLMs. So organizations are using small LLMs called SLMs to answer your for specific activities, and also a set of both ML algorithms and basic tools to ensure that it is able to perform a specific use case and specific or achieve a specific goal aspect. So this is just the various examples of deployments that we have seen, right? Now, with these deployments, then comes is how can you ensure that these systems are responsible? Over to you, Engine.
Yeah. So it's a very interesting point to look at that how a raw LLM is basically tuned and placed into different kinds of application architectures and different formats of tailoring the LLM with the application architectures as well. But a very important question mark which lies is the LLM or is the AI model what is embedded into the application a responsible AI? Lot of GRC standards enforce on AI being a responsible AI and ensuring that it basically covers certain parameters for AI to be called as a responsible AI. So let us look at these parameters and try understanding one after the other. It's very important that AI comes with its own fairness and bias mitigation steps and ensures that all model handling decisions are uh, fair and it's unbiased and it's not disappropriate to different demographic groups and does any kind of nepotic decisions which is basically on this case and ensures that every decision is error free and is a bias free kind of a case. So it's very important that any model which is for prediction or any kind of model which is in the AI enterprise architecture is to be fair and not biased. And of course, today is the case where most of the AI systems are being pressed upon to be called as transparent and explainable AI, making sure that the AI decisions are a decision-making process is understandable to its users and the entire decision-making process is illustrated and put across to the users in a very navigated way and ensuring that there is a compliance coming up into picture and the decision making process being put across in a legitimate fashion is where the transparency of the AI model can improve, and the users and the developers can also understand why the decision was basically made at the first place by the AI systems. And of course, the third important factor is the model security, which is a very critical point because AI ultimately is nothing but a model which is basically trained with legitimate and jettison data, which is nothing but the scrap data. Adversarial attacks using different kinds of prompt injections is sufficient to open up its original behavior and ensure that the entire behavior of the AI is completely changed. And you can imagine the state of the application to which it is basically hooked onto. So model hardening and model security becomes a paramount importance in this particular case in to ensure operational integrity and also to ensure that the entire application behaves in the intended way and not drift away from its existing behavior. Likewise, we have safety as a very important parameter. Look at the case of Waymo or a driverless car situations where AI is live and practical into a driverless system. That is where safety critical operations are basically being performed by AI systems. And it's absolutely very important and crucial to ensure that it's free from any kind of adversarial attacks. So different kinds of safety mechanisms as applied by the OECD AI principles are absolutely crucial for any AI systems to be safe in that kind of an environment, ensuring that the safety critical systems are taken care with utmost priority in such kind of systems. And the fifth one is the data privacy. Larger AI systems are basically being trained with a large consumption of data across, and it becomes very important to look at how the user data is protected in multiple compliance cases like GDPR and other cases, ensuring that there is no leak of PIA or PHI data in healthcare, and there is a minimal user information that is basically used for training that particular model. So data privacy becomes an utmost important consideration for responsible AI component. Sixth is the case of toxicity. by default, AI has a model to have a dual switch scenario where it can switch from a legitimate to a toxic scenarios. So there are cases where information which is generated by AI can be completely toxic and harmful and biased, which can drive the downstream systems to which it is basically connected with, driving the entire system into a different kind of states. And trying to promote an unethical use of the entire AI systems is completely not seen as a legitimate case of responsible AI. So it's very important to ensure that the toxic information is taken out of the entire AI model. And of course, the seventh important case, which every model has been striving to achieve from its inception of AI, is the case of the model accuracy, where we look at higher model accuracy for any kind of function or objective that we are trying to look at. There are different accuracy scoring mechanisms which can ensure that the accuracy is improvised in terms of whatever that we are looking at. And that model accuracy is where we ensure that there are no hallucinations in the output. Higher the accuracy, higher is the trustworthiness of this entire system, and it can wherever the AI outputs are driving the downstream systems in the entire AI ecosystem is what matters in the model accuracy part of it. So with that, over to you, Ranju.
So the question now is that how can you prepare the GenAI application to ensure that you're able to meet your responsible AI constructs? So the first one is to ensure is that the AI that you have is secure, right? So it is secure AI. Now in secure AI, what's the first step? The first step is basically is to identify whether your AI system has vulnerability, right? Vulnerabilities like prompt injection, toxicity, evasion attacks, etc. So what kind of activities should you carry out? Basically, an LLM red teaming, a GenAI application red teaming, pen testing of the AI system infra, and a continuous LLM red teaming activity part. So if you want to comply with ISO 42001 or high trust AI, then few of the requirements of high trust clearly talks about ensuring that the LLMs or your AI systems is being properly tested, right? So basically done using pen testing techniques. The second aspect, once you identify the, so this only the vulnerabilities on the LLMs and the other side. Now, the second one is basically identifying whether there is any risk to the data which has been used by your AI systems, right? Risk like whether the data can lead to a biased decision or whether the data has any confidential or a PI data within the training data part. It's not just training data, it's any data which is being used or being provided to your AI system for making a decision. So here, few of the activities that you can carry out is basically data scanning to identify if the data has any PI data set, or data scanning for identifying whether the data has any bias in your data set. And once you are able to identify those pointers, then is to mitigate those vulnerabilities, right? So how we can go about mitigating it? One of the activities is secure fine tuning of the LLM. So it's a ensuring that the LLM itself is fine tuned again, so that it is not vulnerable to prompt injections and toxic part of it. It's basically ensuring that the LLMs are secure from within itself. So it's like in our normal security nomenclature, it's like patching your applications, patching your operating system. So instead of patching, it is basically secure fine tuning of the LLM. The other controls is basically are ensuring that you have an LLM guardrail, which can ensure that even if you get these kind of an attacks, this attack gets doesn't get processed because the LLM has a specific set of guardrail on what it can actually do. Or you can have an LLM firewall in place to ensure that is able to monitor the request that you're receiving and the response that's being goes out, and the various MLSec operation activities. And with regards to data, you need to ensure that your data is not biased, and your data doesn't have any PI data. So based on this scanning result, you can then determine on how to mitigate the same. So if you actually go for high trust AI systems, these are specific set of requirements in both high trust and ISO 42001 for you to comply with. The second one is responsible AI, right? So when you talk about responsible AI, the main point is to ensure that, hey, is the AI system working within its specific set of guardrails? Whether the AI system is been working within a specified set of goals, and it hasn't gone beyond its defined set of guardrails part. So the first activity to be defined is, if you're going for an agentic AI setup, define the goals. But if you just have normal AI or LLM integrated with your applications, then ensure that your LLM has specific set of guardrails defined. So once the goals and guardrails are defined, then comes your observability part of it, which is basically monitoring of the AI system. Monitoring of AI system is just not limited to monitoring the prompt part of it. It also can ensure that whether the LLM has any model drift, because the your AI systems has any model drift or changing in the way its performance part of it. Is there any data drift on the data set which is being processing? But more importantly, you can have this observability to ensure that your AI system hasn't gone above and beyond its specified set of guardrails. Again, these are specific set of requirements if you're or controls if you want to comply with high trust AI or ISO 42001 part. And once you have your responsible AI in place, then is your trustworthy AI, which through which you can ensure that you can go for AI inventory scans, or basically implement the AI management system or ISO 42001, which ensures that there's a proper AI governance for all your AI deployments within your organization. What are the activities? Are One is basically conducting an AI risk assessment. So for the AI risk assessment, you need to do something like an AI inventory scan to basically identify all the systems where your AI systems is being integrated, and ensure that any third party or vendor that you have is also meets your secure, responsible, and trustworthy AI guidelines part. So these are few immediate steps which you can take to ensure that if you have an AI systems, your AI systems is secure, responsible, and trustworthy. So till now we have only covered a few aspects about responsible AI. If you want more details, we have a detailed certification program called CSP AI. Over to you, Anjan.
Yeah. So, Certified Security Professionals in AI, CSPI, is the world's first in-app accredited course in cybersecurity for AI. It's a course which basically covers the entire triple unique focus on cybersecurity for AI deployments, the GRC compliance, and it covers the majority of the AI for cybersecurity functions. And it has a lot of things which basically it covers under this entire course. And it's thematically focused on the latest edge of artificial intelligence. The entire topics basically navigate from the basics of AI ML, goes through with the transformer architecture and why fine tuning is required. As I basically mentioned, AI is a complex supply chain consisting of data, model, and library. We need to focus at each level to understand what are the vulnerabilities and at these levels, and see how the complex AI supply chain can be secured when it is going into the deployment part of it. And the LLM vulnerabilities and exploits, as well as AI risk management, where we have our own framework which talks about the entire mapping of it into ISO 42001, the high trust AI, then the NISTI RMF, EU AI Act in the governance part of it. and several other frameworks which are basically in the AI space under GRC governance models. Uh, some of the key highlights of the particular program is basically put across,
So,
and you
Anjan, I
have.
think, sorry to cut you out, but as we are running out of time, I think we can just stop it here and we can just open up for
Sure,
questions.
sure.
So, if there are any questions, team, you can just put it in the Q&A and we can answer the same. Sure. So, looks like there's no further questions. So, I think uh, these are our upcoming workshops that we have
I
in place.
think there is a question coming up, if I'm not wrong.
Sure, Anjan. Sure. Ravi. Yeah, Mustafa, you have a question. You can just type it in. Okay, sure.
Okay, cool. I think we can. Okay.
Oh,
Trying to understand the difference between RAG and AGI.
sure. So RAG is basically a retrieval augmented system, a generated system. Just think RAG like a vector database. It's nothing but a database, right? So while AGI is basically the generative A perspective, while RAG is just nothing but a database part. So you want to explain more, Ranjan, on the same?
Yeah. So as RAG is just like a universal database of static information which is basically collected on it. And artificial general intelligence is a case where there is a learning of one domain of AI being transferred onto the other domain. It's a case where it's the AI is basically able to generate facts from it. We are not in a phase where we are trying to generate facts. We are able to consume facts and do a specific task with respect to that particular fact what we are looking at. AGI is far beyond that kind of an ability where the learning from one domain can transfer its learning and to the other domain of AI, and it's a very far off concept.
Sure. Yes, we have the use case for both SDLC part of it, not for in healthcare, Mustafa, part because these are our direct deployments part. But I think you can join the workshop and we'll be happy to ensure that we can give more clarity and we can discuss a specific set of deployments that you have in the environments and where agentic AI can be deployed because the objective of agentic AI is to ensure that it solves specific set of use case. So we just put our LinkedIn profiles. You can add us there, and maybe in LinkedIn you can raise the queries and we can answer it back as well. We do have the AI ops and ML ops in our workshop. And we have the complete details on which applications and to be used and everything there. So for more thing, I think uh, uh, we can join our workshop because it requires more than 1 hour to answer most of it, the queries part. Sure. So with that, we are on time. Sorry to exceed by 3 minutes. Uh, I think I'll just answer the last one. How security is integrated into ops part of it. See what we have currently seeing in the live deployments is the clients are using two approaches. The first approach is definitely is doing a LLM red teaming. So it depends on how we are integrated to the application. So it's called Gen AI red teaming now. Basically it works through your applications part of it and does red teaming. And once it's been identified, then in case if they have budget, they're going for an LLM firewalls. LLM firewalls ensures that all these attacks gets stopped by default, or they are going to ensure that they're deploying a guardrail. So in most kind of deployments that we've seen, they are each LLM or an SLM is doing a specific set of activities and is being now defined through that specific set of guardrails aspects. But we are also seeing where, in some cases, if they have their own LLM deployed within their set environment, like your open source LLMs, then it's been uh, doing a secure fine tuning part. Sure. Um, yes, there are globally recognized. It's an NAB accredited course, Mustafa. So it's a globally accredited course part of it. It just got launched recently. It's been just a year launched, and we have only done 2 workshops for the US region, while we have done multiple workshops. I think tomorrow we're starting our 14th workshop for the Middle East region. So our next US workshop for the NA region, North America region, is scheduled for September 23rd. So that's the reason why you don't see a lot of CSPI holders in LinkedIn. What? Sure. Um, so that's from my side. Our side. Thank you. Thanks for being part of this webinar, and thanks for the questions. And please do look us in LinkedIn, and please do send us a request. And in case if you have further queries, you can share it across, and we'll answer that in LinkedIn as well. Thank you, and have a great day ahead.
Thank you.
Thank you.
Thank you. Have a great day.